All right, so last night I was helping a student with related rates problem, and at that stage of the day, my brain goes to mush, and so I gave a very poor explanation. It's now this morning, reboot the brain, and hopefully look at a situation here where the numbers speak for themselves. All right, so I think the problem last night was the radius of a circle is changing at a certain rate, and what rate is the area changing? I think it's easier to see that process with the square. The numbers actually are very user-friendly. So here's time, so we're going to connect the side of a square, to time, and here's a 1-to-1 ratio, which gives us a very familiar table. And for those of us who have been working with these tables, and the student has been. So 9.006, we can see 0.006 units of change when x is 3 over a very small interval. And we can see that that change in area, 0.006, can be also written as 2 times the side length times the change in the side length. And this is a 1-to-1 ratio of change. So dx dt is 1-to-1. And so we get that 2 times 3, 6-to-1 ratio. All right, the change in area divided by the change in time, and the change in time is the same as the dx, right? It's the same. So hopefully you can see those numbers, the 0.066 times 0.001. A line of work that we generally don't show. We usually jump right to the derivative, dividing dA by dx equals 2x. We usually jump right to that when we say y is x squared and y prime is 2x. We generally do that. Right? Well, it's good to slow things down a little bit and see this intermediate step, especially if we connect time to the side of the square a little differently. And in this case, it's a 5-to-1 ratio. So we look at the change in area from 225 to 225.150. We can ignore this. This is the major change. And so over here, the change in area, 0.150, change in time is just ticking away, right? 0.001. Is equal to 2 times the x value, which is now 15. Over here, it was still 3. All right, so now I have to square this. I get 225. And if I square this, right, 5 times a little change, 5 times a little change, well, that gives me a new length of the side of the square. And we have a dx dt column, where the change in x divided by the change in time, well, hopefully we can see it right here, is a 5-to-1 ratio. All right, so there's our 5-to-1 ratio, 2 times 1530, and there's your numerics working. And that's still a little bit of an awkward explanation, but this student's got a test in a half an hour. So I'm going to upload this and write to her and have her look at that before she takes her test. Okay, so toodaloo.